Okay, everyone, welcome back to CSE 391. This is our third lecture together, and I guess this is week 4. Today we're going to be talking about some more shell commands and talking a little bit more about redirection and show you some more advanced applications of that. Before we start on content, I want to talk a little bit about what today is going to look like and starting with how this is going to fit into kind of the rest of the quarter. So today we're going to start with talk about a roadmap of what the rest of the quarter is going to look like. Talk a little bit more about combining commands to do more expressive or more complex operations. Talk a little bit more about input-output redirection, and talking a little bit about this other command called cut. So where does this week fit into the rest of the quarter? So this is going to be kind of our last week of here's a bunch of new shell commands and talking about those like mechanics. For the rest of the quarter, we're going to focus on some more specific tools and specific applications of those tools. So for example, you may or may not have heard of this tool called Git, which is a version control system for software projects. We're going to spend 2 weeks on that because that's one of the most popular tools used out there in industry, kind of across the board. And so we want to make sure that you know how to use that on your own projects and in a job. And we'll talk about some more applied skills of using these things called regular expressions to help you solve some pretty complex tasks with relatively little writing. And then we'll talk a bit more about kind of the Bash ecosystem, talking about users and permissions, how to write scripts, and then have some time for other things at the end. So what I want us to start with is a quick recap of where we left off last week. So last week I taught you about redirection operators. So taking input from a command, or taking output from a command and saving it to a file, or taking a file and making it the input of a program, or taking the output for one program and sending it to the input of another. So we learned 3 operators for this: the right waka for saving files or output to a file, the left waka for taking a file and turning it to standard input of a command, and the pipe operator to chain 2 commands together, making the output of one become the input of the next. Now, do remember, whenever you're using these operators, they're not interchangeable. They mean very different things. And the kind of mental model I wanted you to think of last week, which I want to remind you of, is think of them as like having types. So this right waka for saving file output, the thing that goes on the left of it should be a command, and the thing that goes to the right of it should be a file name. So all the right waka does is take output from the command on the left and save it to a file. You can't use it in any other context. That's the only thing it does. You can't use the right waka to make one command's output go to another command. It only saves to a file. That's it, nothing more. Similarly, when you want to do standard input redirection, that left waka you put a command on the left and a file on the right, and it reads the file contents on the right and makes that standard in for the command on the left. Now, when you want to do piping, this is where you need 2 commands. So the things on the left and the right must be commands, and it takes standard output from the one on the left and makes it the standard input on the right. So a lot of times a very common misconception is either putting a file name on the right side or putting a file name on the left side. That's just not going to work. It has to be a command for piping. So what I want us... and then just as a bit of a concrete example, I have this program here called standard Inputprogram.java. Actually, let me open up in Vim so we get a bit of color highlighting. This is a very simple program. It just makes a scanner to system.in and types out everything that the user types into system.in. So what we could do is we could say Java standard input program.java. Remember, in this class, we kind of teach you 2 ways of running Java programs. There's kind of the new way where you say Java and then the file name. We also will ask you about the old way. Okay, so I'm going to run this, and then it just says enter some text, and I'll say hello, and it prints out hello, and I say goodbye, and it prints out I spelled goodbye wrong, and I can quit here. Now, if you wanted to preload some input from a file, you could use this left waka here and say, let's do beans.txt, which is a bunch of beans. And it just uses whatever's in that file as standard input. But again, it would not work to say something like beans.txt pipe that. because it's trying to read the thing on the left as a command, and it's not. That's a file name. So I'm going to go ahead and clear that. So now I want to show you a couple other ways of combining commands together. So this is less about making explicit relationship between their inputs and outputs. This is more about run this command, then this command. So the first one I'm going to teach you is this double ampersand, which is kind of like the AND operator in Java. So you use a command on the left and a command on the right, and it first runs the first command and then runs the second command. But with one caveat. It only runs the second command if the first one doesn't crash. It's kind of a lot like short-circuiting in Java, where if the first thing on the AND is false, it doesn't even bother evaluating the right-hand side. It's a very similar thing here. So here's what I'll do. I'll type foo, which is a command that doesn't exist, foo and cd dir1. I won't cd into dir1 here because that foo command failed. It didn't exist. But if I type ls and cd dir1, well, first I ls, and because ls succeeded, it then goes into dir1. Let me go back up again. There's also a way of chaining operations together, kind of like OR in Java. So you could say something like foo or cd dir1. Now, OR works kind of in the opposite way, where it says if the first command fails, you could still run the second one. So we run it, I cd into dir1 just fine. But now, OR has a slightly different meaning, though, if the first command succeeds. If the first command succeeds, then it's not going to run the second command. Kind of like in Java, when the left-hand side of an OR is true, it doesn't even bother evaluating the right-hand side. So you have to be a little bit careful when you're thinking about these ANDs and these ORs when combining them for bash commands. Now, do note, the OR kind of looks like a pipe, but because you have two of them, it's being registered as OR. There's one other one. If you really want to say first run this, then run this, no matter whether the first one succeeds or not, there is a way of doing that. Use semicolon. Semicolon, kind of like Java, is like an end of line of some sort. So ls semicolon cd dir1 will first run ls, then run cd dir1, and it will run it no matter whether or not that first command succeeds. I'll say out of all of these I just showed you, by far the most common is this double ampersand operation, because almost always you don't want to run later commands if an earlier command failed. So usually kind of one very common way or common application is first compile a Java program, so hello world.java, and then run hello world. And this is using that older Java syntax for compiling, right? Java C to compile the Java file, and then Java class name to run it. There you go. So that is another common thing. And again, for some reason, I don't know why, but for on Autu specifically, I'm not able to run Java commands the old way. But I looked into this again, and it seems like on every other computer I try, you can run Java programs the new way or the old way. But for some reason on Autu, it only supports the new way right now. I already emailed support. Hopefully they'll get back to me soon. So there's that. That's how you combine operations. So now I kind of want us to do a little practice, a little case study practice on, let me try to compile, using that old Java C program, compile all the Java programs in this directory. There's quite a few Java programs. And so you might remember, we've actually talked about this already last time. You could use the Java C command and then type star.java to expand with the wildcard to all Java programs in this directory. Now it fails here, and that's expected. One of my files is called compileerrors.java, and it has a compiler error in it. So this is okay. The Java C program fails if any of the things you tried to compile don't compile. But just suppose for this example, I didn't want you to use a wildcard in the Java C program. What if I wanted to ask us, is there another way of doing that? Just for example's purpose. There's nothing wrong with the command I just typed. So what if you wanted to try something like, maybe something that might come to mind is, oh, well, you might not have noticed this, but you can type ls star.java, and it will just list out all the Java files, all the files that match this name. So you might think, well, could I do something like ls star.java and then pipe that into Java C. And that is what I actually want you to take a second to think through in our first question for today. So write in a few sentences, what do you think would happen if you were to run this ls star.java pipe into Java C? Would this work? Why or why not? Okay, so hopefully you had some time to think about that. Let's go ahead and try running this command and seeing what happens. It crashed. Well, it crashed, and it prints out a bunch of stuff. What it's saying, what ended up happening here was it was not very happy with the fact that we tried to pipe input into it. Java C, if we type in man Java C, Java C takes the files as arguments. So when you call Java C, you have to pass in file1.java, file2.java, etc. Now, piping doesn't do this. Remember, one of the things we stressed last week was the difference between an argument and standard input. When we say ls star.java pipe Java C, we're taking that list of files that ls.star.java outputted. There's nothing wrong with this, but then we take that output and try to pipe it into standard input for Java C. But Java C doesn't take standard input. It doesn't read from standard input. It only is asking for arguments. Now, you might wonder, how would I know that Java C doesn't look at standard input? And that's all from the man commands, or the man pages. So for example, go look at word count. Word count was one of those ones where it reads from standard in or it reads from a file. And it's a bit confusing. It's not in the most obvious place. Oh, it doesn't show it on here. Oh yeah, sorry, it shows at the top. On my Mac, it showed it in a slightly different place. With no file, or when file is dash, read standard input. So you know from the documentation that it's able to handle both. If it doesn't say that, if it says it only takes arguments, then it only takes arguments. So it'd be nice if there was some way to convert this kind of standard output that came from ls.star.java that got sent to standard input from the pipe, and maybe kind of turn those into arguments for Java C. Enter the command xargs. Xargs is a program that lets you do this. It converts standard input to command line arguments, or we also call those parameters, so that you can do these kind of piping things together. So let me show you how to do this first. You just change this command to call the xargs command. Now notice what this is doing is, the way you read this command is this whole thing is you start by lsing star.java. That prints out to standard output a bunch of file names. We then pipe that output to the xargs command. Now, not just the xargs command, but we passed in the string Java C as an argument to xargs. So it says xargs took that Java C as an argument and will read from standard input that it receives and kind of munge the command line around a bit so that it runs Java C with the standard input as the arguments instead. And so now if I run this, it still fails because of that compiler error, but it tried to compile it. To make a little bit clearer that this is actually doing what I'm saying it's doing, let's just break up this command in a couple steps. So start with ls.java, and I want to save it to a file. Maybe we'll call it tocompile.txt. And then what I'll do is go vim tocompile.txt to open it up. And I'll just delete compiler errors.java so we don't compile that one. Then what I'll do is I will go through and cat tocompile.txt and pipe that into xargs Java C. And now everything runs all nice. If I ls, you see a bunch of class files there. So this command did exactly what I wanted it to. Now, I'm going to pause for 1 second, let that sink in. Cat tocompile.txt is just going to print out a bunch of file names, and then we piped that into xargs, and xargs is the program that takes standard input and converts it to arguments for the program you pass into it, which in this case was Java C. So this kind of line of code is equivalent to Java C command args program.java, hello world.java, mystery.java, simplegrep.java, etc. It's a very similar program. One thing I have to mention about how I wrote this is I kind of wrote this in a way that's like not the best style. It's a bit of an anti-pattern. Whenever you see yourself saying cat file name and then pipe, why did we write that? We were trying to get the contents of the file to standard out and then pipe it so it becomes standard in. Why go through all the process of like writing out the cat command and running it to get its contents onto standard out when we have a file direction operator that converts a file directly to standard input for us? So you would say to compile.txt. So really, whenever you see yourself saying cat and pipe, that you should stop yourself and be like, oh wait, I should just use this left waka here. Even though they're basically equivalent, this is a bit easier to reason about and is slightly more efficient, but more as just a pattern thing. Like this is how people write this using the bash mindset or the Linux mindset. Okay, so do note that xargs will come up whenever you want to convert standard input to command line arguments. Okay. Now, why go through all this process of doing this when I told you earlier that javac star.java works? It definitely does work. I mean, minus that one file with the compiler error. Why go through all this process? Well, it turns out I have some directories in here that have some other Java files, dir1 and dir2. dir2 has inside of it a dir3, and etc. Now, what if I wanted to compile all Java programs in this entire directory, including all the subdirectories? javac star.java won't do that. It won't compile anything in those subdirectories. How would you know? Well, try ls star.java. These are the files that get printed with star.java, that star.java expands to. It doesn't go into any of those subdirectories. There's one workaround here. You could say something like javac star.java, dir1 star.java, dir2 star.java. Oh, wait, and that dir2 had a dir3 inside of it, star.java. But you can already see right now how kind of impossible this will be if you had a lot of directories or anything like that. So the reason we introduced xargs was because it's really useful in this tool chain where we want to say, do something to this list of files that I find from somewhere else. And that kind of leads into the next command I want to show you, which is the find command. So the find command is a lot like grep in some sense, where grep takes a pattern and searches files to print out each line that pattern appears in. Find searches your directories for files that meet some query. Okay? So there's this find command here. So let me start by showing you how to find all the Java programs in this directory. You say find -name star.java. So this is what this is doing, is it's almost like a Google search of some sort. I'm saying find all the files that's name matches this pattern. And find does this recursively. It goes through all the subdirectories and prints that out. Now, the first thing you might be wondering is, hey, wait, I thought you said when we introduced this idea of flags that all the flags were like -1 letter. Well, the way you find this out is always from the man page. And we can search for the name thing. Some of these flags are 1 letter, but a lot of them have more characters in their names. There is no requirement that flags are only a single letter. This one just said this argument here here needs to be the -name thing. This is one of the annoying things about find in particular, but just most bash commands, is that there's not really a kind of standard convention for these things. A lot of places they use double dashes for full word argument names, but not here. Find used this thing. So we're going to say find star.java, and it runs all these things. And so now if I want to compile all these, maybe I can try something like find -name star.java to get whoops. Let me quit this because I accidentally hit enter. Oh, I hit enter again. Find -name star.java to get all the Java files, and then maybe I'll pipe that into javac. Is that going to work? No, it's the exact same problem we had before. Pipe sends that output to standard input. So if I want to convert this command line arguments, I have to use the xargs program. And now it ran, again, getting that compiler error, but that means it's working because I have that one file with the compiler error. And so again, it is so important that we're stressing this idea of the difference between arguments and standard input. I've gone ahead and, just to drive that point home, I've gone ahead and edited that simple grep file that I showed you last week, Java. I also put some print statements in here saying, hey, I'm reading from standard in, or I'm reading from some arguments. Remember, in this simple grep, if the argument's length is 1, it reads from standard input. Otherwise, it's going to go read through all of those file names you passed it. And so you could do something like Java simple grep.java, search for the string bean in veggies.txt. And first thing it says that I'm reading from some arguments because I passed in the arguments there. But if instead you didn't include an argument there, it's now saying, oh, I'm going to read from standard input, and you can type things in here and it will print them out as you see it. And this is no different than if I said, hey, what if I wanted to pre-populate it with the contents of veggies.txt? You can run that. Okay, so it's really important to remind yourselves of var, that vertical pipe is for taking output to input, and the difference between standard input and command line arguments. So I want to, in this video, I want us to do one last thing together. I want us to try one more practice problem. I want us to say, suppose I made a file called toRemove.txt, and in that file, I just had a bunch of file names, one on each line. I want us to remove all of the files that are listed here. So what command helps you remove, and how can we actually go about trying all this? So take a minute or so, try to tackle this. How can I remove all the files listed in toRemove? Okay, so hopefully you had some time to try that out. Let's go ahead and try to tackle this together. So hopefully you got to the point where if you know you want to remove something, you know you want to do something with the rm command to remove. And it's not going to work. Let me actually go ahead and make a toRemove.txt. And maybe I'll, what file should we remove here? Let's remove that compile errors.java, and let's remove mystery.class. Compile errors.java and mystery.class. So I can't just say rm toRemove.txt because that's going to actually remove the file that I'm interested from reading from. And just to show us that this file has contents and that it exists, we have this here, compile errors.java and mystery.class. So how am I going to actually go about reading these file inputs and somehow passing that to rm? So you might think, oh, well, I could try to do something like cat toRemove.txt and then pipe that into rm. First warning bell that should go off is we just saw that cat piping pattern, which is not what we want. And so usually you think you might want something like, oh, well, let's use this left waka instead, toRemove.txt. And this won't do anything. The reason is, just like Java C, rm does not read from standard input. It only pass its names, file names, to remove from the arguments, like the command line arguments. So what does that mean we need? It means we need to use xargs. So I'm going to go back to writing it that first way with the cat and the piping, cat toRemove.txt, and then xargs rm. And that's going to remove, do I have a typo? Compile errors. Oh, I put 2 R. I misspelled one of these things, but we'll just edit it here. We put 2 R's in the wrong place, I guess. Or maybe that is how you spell errors. I don't know anymore. Let's try running this again. Mystery.class, did I spell? Oh, because I already ran that. So Java C, mystery.class, mystery.java, and then let's run this command. Compile. Oh, because I already removed it. Right. So I already got rid of it, so now that's failing. But it went ahead, and I ran this command too many times. But it removed that mystery.class too. So it went through and removed all of those. But again, whenever you see this cat pipe, you know that's kind of an anti-pattern. So to fix that, you use our left waka to read from input. So this is what I'd argue is the best answer. Xargs rm to know, hey, take whatever's coming from standard input and pass it to rm as command line arguments. And what input do I want? I want to remove.txt. So there we go. But I want to show you before we end one last way to try to do this compile all Java programs that you will probably see out there in practice. And I wanted to show this to you, but it's one that we don't usually recommend that this is a style that you use always. You need it sometimes. We'll talk about when you need it later. But let me just show you the command first, and then I'll explain it. Find-name star.java. So this is using this thing that using this feature in Bash that kind of like hacks into the command line in some sense. It's not bad hacking. But the way you read this is it's running the Java C command, and you're saying this is what I want to pass as arguments. But because you're using this $ parentheses, what it's going to do is first run that command and take its output and stick them in as command line arguments. So it will run that find-name star.java, gets its output, and because we're using this $ parentheses, sticks that directly as the command line arguments. So it actually evaluates that before running the Java C command, even though you kind of wrote it together on one line. Now, for small tasks, this is fine, maybe even preferred because it's fairly more straightforward to read. However, this doesn't really work for large tasks, like where you want to compile like thousands of Java programs or do something like that. Xargs is built to be very efficient in the sense that like it's able to do things with parallelism, like running things on multiple CPUs. It's built for efficiency, and so for large workloads, you usually find that xargs is preferred, but we wanted to show you that this is a thing. So this is how we do input-output redirection, how we run multiple commands together, and practicing this difference between input, like standard input, and arguments to a command. In the next videos, we'll talk a little bit more about some more standard input, standard output stuff, and some more useful commands that you can use when processing files.